Hey everybody, welcome back. We're going to talk about 3D figures today. So I have attached a copy of these notes as a PDF document on Schoology. I would really like for you to be able to get that document and follow along as you watch the video. So if possible, you could print it out, you could save it in PDF Expert, or you can just kind of go back and forth from the video to that document. Okay, so feel free to pause the video and rewatch whatever you need to do to help you best. Okay, last week you were working on two-dimensional figures, our parallelograms and triangles and trapezoids, and we were finding the area of them. So now we're going to focus on three-dimensional figures. So if you look right here on your notes, let's talk about those dimensions for a minute. If you have something that's one-dimensional, that would be like a line, okay? And the dimension that we're referring to here would be the length. If we have a two-dimensional figure, okay, that would be more like a rectangle. So then you would have a length and a width. That's what your two dimensions are. And when you have a three-dimensional figure, okay, we'll see how good my drawing skills are. Not too good, are they? But a three-dimensional figure is going to have a length, a width, and a height. So these 3D figures, sometimes are called solids, are going to stand up. They aren't going to just lay flat like a rectangle or a square or a triangle, but they have a height to them. That's what makes them three-dimensional. Okay, sometimes we use the terms base and height. They all kind of mean the same, and they can be, I guess, interchangeable, maybe, if you want to say. In other words, it doesn't really matter what part of the prism or the rectangle or whatever your figure is. It doesn't matter what you refer to as the height and what you refer to as the length or the base, as long as you know and you only have one dimension that you're calling that. Does that make any sense at all? Okay, so basically what I'm saying is if we have a rectangle and I say this is the length and you say that's the width, that's okay. Somebody else might look at that same rectangle and say, I'm going to call this the width and I'm going to call this the length. Okay, somebody else might look at that rectangle and say, I'm going to call this the base and I'm going to call this the height. And that's okay. Okay, they can be different as long as you know what it is that you're referring to when you use those terms. Okay. I feel like I kind of got off on a tangent there. Anyways, 3D figures have a length, a width, and a height. You can see in the image over here some examples of three-dimensional figures. Okay, you guys have worked with these in the past. We have cubes and pyramids and prisms and cylinders and cones. All sorts of figures here. Okay, we're going to focus in on mostly prisms and pyramids today. So prisms are special because they have two congruent bases. A cube is going to be a type of prism. A cube is kind of its own special thing because all six faces are the flat surfaces, but all six faces are congruent or equal on a cube. Okay, a cube is made up of 6 squares, basically. A rectangular prism, so like we could say that what you might call the top and the bottom are the bases. Okay, so there's 2 congruent bases, and then you have your other sides, which we refer to as lateral faces. Okay, you'll see that as you get older, not real important right now. This one right here is a triangular prism because you can see here we have these 2 triangle bases, and then your other sides are rectangles. Those are the lateral faces. So we're going to be looking at these 3D figures as if we were to cut them apart and lay them out flat. Okay, and whenever you do that, you're going to see what we have over here in this second column. We call those nets. Okay, so it's when you take a three-dimensional figure and you draw it flat to see it like, I guess, the two-dimensional version of that. So it's like you're opening it up and you're laying it out so you can see each face that makes up that solid figure. Okay, And then we're also going to be focusing on pyramids. Pyramids are special because they only have one base. So here you can see we have a square pyramid. So the base is a square. Opposite that base is a vertex. And then the lateral faces on a pyramid are triangles because those faces have to come up to make that vertex. This next one is a triangular pyramid. You see how the base is also a triangle, and then the other three faces are triangles as well. Okay, and again, we have the nets here that will show us what it would look like if we were to cut it apart and lay it out flat. So if you are tired of watching a video, you can pause this or stop it, and you can go on and do assignment number 2 for this week because it focuses just on practicing identifying the nets for different 3-dimensional figures. And then you can come back and watch the rest, or if you'd like to watch the rest of the video now, you're welcome to do that. Okay, so as we work with our 3-dimensional figures, we will be finding the surface area. Okay, if you remember back with our 2-dimensional figures, like let's just say a rectangle for example, we could find the area of a rectangle, and we also talk about the perimeter of a rectangle. So the area is the space that's on the inside of any figure, and the perimeter is the distance around the outside edge. All right, now when we get to 3-dimensional figures, we are going to talk about surface area, and eventually you'll get to volume. So surface area is the area around the outside surface, kind of just what it sounds like. So if I had a box and I wanted to wrap it with wrapping paper, or I wanted to paint the outside of a box, I would need to calculate the surface area. Okay, if we're going to fill our figure with something, that would be volume. And we'll talk about that later. So we're going to focus on surface area today, which is the area around the outside of a figure. And to calculate the surface area, we're actually going to find the area of each face and then add them all together. So here we have a rectangular prism. And then in the second image, we just took that prism and we laid it out flat as a net so we could see each face. Okay, so to calculate the surface area, we're going to find the area of each face, and then we're going to add those all together. So I'm going to zoom in here. Hopefully you have your paper where you can do this with me, or if you want to find that, you can pause the video and then come back. Okay, so I'm just going to get started here. I'm going to start with what I know. So I see numbers over here. I'm going to focus in on this face. It's a rectangle, and I know to find the area of a rectangle I have to do length times width. So I'm going to do 6 times 4. Okay, and I know the area of this is going to be 24. If this is 4, then I know this is also 4 because those are the same. So here's another rectangle exactly the same as that last one. So 6 by 4 again is going to tell me the area of that rectangle is 24. Okay, now I'm going to switch colors here. Maybe that'll help you see this better. If we go down here to this little rectangle, I know this is 2, and then this and this are the same, so they're 6. So we have a 2 by 6, which means the area for this is 12. Okay, and the cool thing about a rectangular prism is that each face has a matching partner, I guess, or the opposite faces are always congruent or equal to each other. So if you think of like a tissue box, the top and the bottom are going to be exactly the same, the front and the back are exactly the same, and then you have your two sides that are exactly the same. So that's what we're seeing right here. Okay, and then we still have this little part right here. So this is 2 inches by 4 inches. So 2 by 4 is 8, and this one is also 8. And then you're going to go through and you're just going to add all those numbers up. So 12 plus 12 plus 24 plus 24 plus 8 plus 8. And we would find that our surface area is 88 inches squared. Okay, just like regular area, we always measure in square units. Okay, here we go with our next figure. This one is a triangular prism. You can see it's made up of two triangle bases, and then you have the three rectangular faces. Okay, so we want to find the surface area, which means that we have to find the area of each of those faces, and then we'll add them all together. All right, I'm going to start with the triangles. So if you look up here at this triangle, remember for triangles to find the area, we have to do base times height divided by 2. So this triangle is 2 centimeters times 1.7, and then we'll divide that by 2. Okay, so hopefully you still have your calculator handy, and whenever you do that, you'll find that you get 1.7. Okay, and then there are 2 of those, so we can actually take 1.7 and multiply it by 2. All right, 1.7 times 2, and that will give us 3.4. So that's the area of both triangles combined. Okay, and then we have our rectangles. So I see that this is 12, and this side is 2. So 12 times 2 is equal to 24. And then there are 3 of those rectangular faces that are exactly the same. So we can take 24 times 3, which is 72. Okay, and then we want to add 3.4 and 72. And that would give us 75.4 centimeters squared as the total surface area. Okay, so see how we're kind of taking what we learned last week, finding the area of those different two-dimensional figures, and we're using that to help us find the surface area of our three-dimensional objects this week. All right, we're going to do one more together. If you'll take a look here, it says Sherman is painting the surface area of a wooden box in the shape of a square pyramid. The net for the box is shown below. So I would like to challenge you to pause the video and work this one out on your own, and then you can hit play and see if you come up with the same answer that I do. All right, good luck. Okay, so I started with the square right in the center here, and I see that one side is 12, and they told us that it's a square pyramid. That's how I knew for sure that figure was a square. So 12 times 12 is 144. That's the area of just the square. And then for the 4 triangles, this was 12. The base was 12 and the height was 8, so I did 12 times 8 divided by 2 because it's a triangle, and that gave me 48, and then I took 48 times 4 because there are 4 of those triangles, and that was 192. And then I add the square plus the 4 triangles and got a final answer, or the total surface area is 336 inches squared. All right, so you guys can go on ahead and do the practice questions. Remember, you can come back and watch the video anytime if you get stuck. Good luck.